They told us the what part, but they did not tell us the why part. So we know what, but we do not know why. The reason was never made clear. So we know what happens, but not why it happens. And if you can see the picture, you would obviously be able to understand what I'm talking about. What we have got on the left side is Herb's apparatus, and on the right side we have got a huge iceberg floating, and you can see that the major part is underwater and a small part is above water. So we know what, but we may not know why, and today we will explore the why part. The one which we are going to describe is important because they have wrecked many ships. They have wrecked many ships, but at the same time, they save aquatic animals. Right? They have wrecked many ships. Many ships have been wrecked. Thousands of human lives lost. But at the same time, they are also responsible for saving aquatic life in cold countries. Let us see more details about this. What we are talking about is the anomalous expansion of water. So we have been taught in school what is anomalous expansion or what is the meaning of anomalous expansion. That is in the range of 0 degree to 4 degrees Celsius. Only in this range, 0 degrees Celsius to 4 degrees Celsius, water shows an anomalous behavior. Water exhibits an anomalous behavior. It contracts on heating and expands on cooling, but only in this range 0 to 4. Otherwise, we know what happens. Normally, in warm water, you can see the molecules are apart that we have shown diagrammatically, the separation between molecules. And in cold water, the separation between molecules you can see is much reduced. The molecules get closer to one another when the temperature goes down, but that is till 4 degrees Celsius, not after that. The reason for this is the main topic we are going to discuss in this video. So we have seen that if the temperature is higher, that means warm water, the distance of separation between molecules will be longer, and if the temperature is lower, that means cold water, the distance of separation between the molecules will be shorter. So warm water, you can see the distance of separation between molecules. When you cool them, when the temperature falls, the kinetic energy of the molecules decrease. The kinetic energy of the molecules decrease. Then what happens? The molecules get closer and closer, right? And the volume decreases. The molecules are getting crowded. The distance of separation decreases and the volume decreases. And the smallest distance of separation between molecules that happens in case of water at 4 degrees Celsius. At 4 degrees Celsius, the water molecules are at the closest possible distance. They can't get any nearer. No further reduction of distance between molecules is possible. They cannot get nearer to each other than this. Now, what will happen if you reduce the temperature further? The molecules cannot get any closer. Why? Because the negative pole of this molecule, the negative pole of this molecule will repel each other. You can see the big circle, that is hydrogen, and the two smaller circles, that is oxygen. So this oxygen has a negative charge, and here also oxygen with negative charge. Negative will repel. Just as north pole of a magnet will repel the north pole of another magnet, south pole of a magnet will repel the south pole of another magnet, a negative charge will repel another negative charge, a positive charge will repel another positive charge. Now negative repulsion, negative pole of one molecule and the negative pole of another molecule, they repel each other, they push away each other, so they can't get any closer. But you are continuously reducing the temperature. The molecules are already at the closest possible condition, the minimum volume. Now it is not possible for the molecule to move any closer. And you are reducing the temperature 4 degree, 3 degree, 2 degree. So what is the option left for the molecules? They can't get any closer, and you are going on reducing the temperature. The kinetic energy is going down and down. What the molecules will do? The molecules teach us where there is a will, there is a way. Where there is a will, there is a way. Getting closer is impossible. The temperature is going down and down. The molecules feel the necessity to do something. They have to do something. And they teach us the moral where there is a will, there is a way. Let us see what the molecules actually do when the temperature is reduced further down. So, did I say where there is a will, there is a way? There is another thing they teach us. Unity is strength. They teach us two things. Where there is a will, there is a way, and unity is strength. So when you are reducing the temperature below 4 degree Celsius, now the molecules cannot come any closer, but the temperature may be 3 degrees Celsius, 2.5 degrees Celsius, 2 degrees Celsius. So what they do? They come together as a pattern, a group. The pattern is forming, not completely formed, but a sort of pattern tends to be formed. And this is called a macromolecule. A macromolecule, that means the group of molecules forming this pattern or something like this, they behave as a single unit. A single unit, macromolecule, but actually there are several molecules. So unity is strength, and where there is a will, there is a way. When the molecules cannot get closer to each other, they combine, they unite and form a pattern, right? And this is how they deal with your reduction of temperature. So you are reducing the temperature below 4 degrees Celsius. They were tending to form a pattern, and at 0 degrees Celsius, when water freezes to ice, the pattern is fully formed. Perfect pattern, fully formed, firm, established. So now it is ice. And that time the pattern was being formed. And now the pattern is completely formed because it has frozen to ice. And these macromolecules, that is, molecules arranged in this pattern, the macromolecules take up more space than individual molecules. These macromolecules arranged in this pattern, these macromolecules will occupy more space. They will take up more space than individual molecules. That is the reason water expands after 4 degrees Celsius down to 0 degrees Celsius. After 4 degrees Celsius, the water did not contract, the molecules did not come closer, but they started forming patterns. And when water freezes to ice at 0 degrees Celsius, you have got perfect patterns. And the space taken up by the macromolecules is more than the space required for individual molecules. That means the volume increases and the density decreases. That is the reason ice occupies more volume than water, although ice is colder. the density of ice is less than density of density of water, sorry, density of ice is less than the density of water because the volume is more. Why the volume is more? After 4 degrees Celsius, why do we get water expanding? Because they have formed macromolecules, and these macromolecules are taking up more space than individual molecules. So taking up more space means more volume, and more volume means lower density. So from 4 degree down until it freezes to ice at 0 degree, the macromolecules are being formed, more volume and lower density. And when you finally come to 0 degree, when water freezes to ice, you got this perfectly formed macromolecules and they take up more space than individual molecules. So the volume of ice is more than the volume of water, and the density of ice is less than the density of water, and ice will float on water. So in summary, there's a quick comparison. See how the molecules are arranged in water, liquid water, and how they are arranged in ice. In ice, they form perfect pattern, occupying more space. But in water, they are close to each other, but they are individual molecules. That's why they take up less space. Right? Ice expands or water expands when you change to ice. Why? Because we are not getting individual molecules, we are getting macromolecules, groups of molecules taking up more space than individual molecules. You can see here. And also that these are stable. These are stable. That is why it is solid. And here, unstable, constantly breaking and reforming. That's why water is liquid. That's a quick comparison of a look, a casual look, a cursory look at the molecules of water and the macromolecules of ice. So now you can understand why ice floats on water, because ice is taking up more space because of the macromolecular pattern, and in liquid water it is many individual molecules. That's why ice floating on water. And many a shipwreck has been caused by icebergs. Icebergs, where only a small part of it is above water, a large part is below water. Several shipwrecks have taken place, and yet this is a property due to which aquatic life is preserved in cold countries. So it's both a blessing and a curse. So icebergs causing shipwrecks and loss of thousands of lives, and yet the same property of water preserving aquatic life in cold countries. But the molecules have taught us two things: where there is a will, there is a way, and unity is strength. And now the question is why they don't teach this in school? Because this is not very difficult to understand. In say classes 9 and 10, they have sufficient maturity. So even if they don't include this in the syllabus, they could have given in the textbooks a short note. Not so elaborate, a short note, say about just 3-4 lines, and also mention that this is not in syllabus so that interested students could have gone through it. And incidentally, this question was raised, and I made the video. Actually, the inspiration came from one of my online students. So thanks to Jaita for raising this question. And then I explained, and actually it was a group, and the students understood. It's not that the students did not understand. So actually the textbooks, even if it is not in syllabus, they should have a short inset mentioning this in brief, and then mentioning it is not in the syllabus so that interested students could have got an insight. Anyhow, this was an interesting discussion. We will meet again with more interesting videos. Till then, thank you and goodbye.